Hello, thank you for joining us today. My name is Gigi Launchpa with the Fort Hays State Makerspace, and this is one of our videos that is going to show you preparation processes for doing a high altitude balloon launch. One of the first things we will need to do is pick a date for our launch. We want to be able to predict where the balloon will fly. We can do this using a website called habhub. The website uses data from the National Weather Service and other sources to make a model of what the atmospheric conditions will be like on any given day. Now this only works up to about 10 days in the future, so we have to keep rechecking the predictions as we get closer in time, and they'll get more accurate the closer we are to our launch day. So typically we'll check the website several times in the days leading up to a launch. And it may end up that we have to move the launch forward a day or backward a day to get favorable weather conditions. Things that we are looking out for especially are making sure that the balloon will not land in a body of water such as Wilson Lake or Kerwin Lake or the Cheyenne Bottoms wetlands. We have had a balloon land there, and it was quite a job to retrieve it, so we don't want to do that if we can help it. There are also military facilities here in Kansas that we want to make sure the balloon will not land in. The Smoky Hill Air National Guard Range, located just southwest of Salina, and the Fort Riley Military Reservation, located between Junction City and Manhattan. The first thing we need to do when opening up habhub Predictor is to enter in our launch site. We will be launching from campus for this project, so we enter in the latitude and longitude of Hays, Kansas, or you can use a pre-saved location like I've done here. The next thing you need to enter in is the altitude of your launch site in meters. Where we're launching here in Hays, that's a 616 meter altitude. Next we will enter the time and date. We do not use our local Kansas time zone. We use what they call either Greenwich time, UTC, or Zulu time. To find this time, just add 6 hours to our local central time. And finally, we need to enter 3 parameters related to the balloon. We need to enter its ascent rate in meters per second, the estimated burst altitude in meters, and the descent rate in meters per second. These may vary depending on what your balloon payload is and what your goals are. Typically, an average launch, we ascend at 5 meters per second, burst at around 30,000 meters, and descend at about 10 meters per second. Now that we have entered all the parameters, go ahead and click the Run Prediction button in the bottom right corner. The predicted path will be displayed. It will indicate the estimated burst location and the estimated touchdown location. At this point, we want to check to make sure that it is not landing in any unfortunate locations. It's a good idea to screenshot this projected path and then try some other dates and times, perhaps the day before, the day after, a couple hours later. These can make significant differences in the projected path. Then it's recommended to continue to check the path on the days coming up to your launch date. If you check it every day, screenshot it, then you can compare how the predicted path changes as the weather prediction changes. Typically, if you run a prediction immediately before your launch and you have all your parameters entered correctly, it will give you the touchdown location within just a couple miles. So this has been your introduction to the habhub prediction features. Watch the rest of the videos in this series for the next steps. Thank you.